So this thing is also interesting when it comes to fluid vaporization. Vaporization is a change from the liquid state to the gaseous state is known as vaporization. A change from liquid state into gaseous state, we call it vaporization. We call this one vaporization. So when we say vapor pressure, the liquid is kept in closed vessel. The vaporization takes place, the molecules escape from the free surface of the liquid. The liquid is kept in, the vaporization takes place, the molecules escape from the free surface of the liquid. So these vapor molecules occupy the space between free liquid surface and the top of the vessel. So these accumulated vapors exert a pressure on the liquid surface. And this pressure is called the vapor pressure of the liquid. The other concept is surface tension. Surface tension is defined as a tensile force acting on the surface of a liquid in contact with gas or on the surface between two immiscible liquids such that the contact surface behaves like a membrane under tension. Due to molecules attraction, liquids have properties of cohesion and adhesion, right? Because as long as there is a molecular attraction, those liquids have a properties of cohesion and adhesion. Cohesion is due to force of attraction between molecules of the same liquid. This force is very small, but adhesion is due to force of attraction between molecules of two different liquids. So it's same liquid, but between two different liquids. So this molecules of the liquid and molecules of solid surface. We can say it like this, which is a really interesting topic, surface tension. The other one is bulk modulus. Bulk modulus is defined as the ratio of change in pressure to the rate of change of volume is called bulk modulus of the material. So bulk modulus change in pressure over volumetric strain. So here we have volumetric strain is the change in volume, this one, divided by original volume. So the negative sign of dV, we have negative sign, so indicates the volume decreases as pressure increases. When we say negative, it means that the volume is decreasing as the pressure is increasing in bulk modulus. So the main concept of bulk modulus is like change in pressure over volumetric strain. The change in pressure over volumetric strain. The other thing is compressibility. The compressibility of a liquid is the reduction of volume of fluid due to an external pressure acting on it. Like the reduction of the volume of a fluid due to an external pressure applying on it. We call this compressibility. So a compressible fluid will reduce or change in volume in the presence of external. So let's say if there is an external pressure, the fluid will reduce its volume due to this external pressure. We call this compressible fluid. So compressibility is reciprocal of bulk modulus of elasticity, which is defined as the ratio of compressible stress to volumetric strain. So this is the reciprocal of the bulk modulus that we seen before. So its unit is Newton per meter square, and in nature all the fluids are compressible. Gases are highly compressible, but liquids are not highly compressible. Yeah. So we can say here, gases are highly compressible, but liquids are not highly compressible. So the other concept is the relationship between bulk modulus and pressure for gas. The relationship between bulk modulus of elasticity K and pressure for gas for the different process of compression are as isothermal process, isentropic process, adiabatic process. I think we've seen these concepts when we were talking about the thermodynamics lesson, so I'm not going to repeat this process. The other thing is capillarity. Capillarity is defined as a phenomenon of rise or fall of a liquid surface relative to the adjacent general level of liquid in a small tip, when the tip is held vertically in the liquid. It can be rising or falling of the fluid or the liquid. Capillarity occurs because of intermolecular force between the liquid and surrounding solid surface. Between the liquid and solid surface, when there is intermolecular force, they cause what? Capillarity. And due to pressure of cohesion and adhesion, which causes the liquid work against gravity. So it's expressed in terms of centimeter or millimeter of liquid, and its value depends upon the specific weight of the liquid, diameter of the tip, and surface tension of the liquid. So capillary raise means, like as you can see here, we immerse this tip and the water is raising here the liquid. So if the glass tip is inserted vertically in the liquid like this, say water, the liquid will rise in the tip. The liquid will rise in the tip above the level of the liquid surface, which is this one, the edge which is above the level. So this one is known as capillary raise. And capillary And the second one is capillary depression. This one is like you have this tube, but the concept is if the glass tube dipped vertically in liquid, say mercury, the level of the mercury in the tube will be lower. This one, because this edge is lower than this level, then we call this thing capillary depression. Here we have two forces acting on the mercury inside the tube, so we call this one capillary depression when the level of the fluid is lower than the surface level of the tube or the container. Okay, so thank you. I think it was really interesting topic. As I said before, this is not detailed or something. This is an introduction, but as time goes by, we will try to come up with different topics with different lessons. So what I need from you guys is try to follow with the lessons that I share. And if you have any questions, you can ask me down in the comments below. I will try to reach out as soon as possible. And the other thing that I want to say is I might say different things. I might make a mistake when I lecture because it's like kind of exhausted when you try to speak for an hour or for 30 minutes. So maybe due to that I might say some unnecessary things, so sorry for that. And I want to say thank you for your time, and I wish you all the best in your entire life, in your entire journey, especially for those of you who want to pursue your career in this field. So wish you all the best, and thank you.